Algebra 1, factorizing expressions 3. The expression for factorization 3 must contain exactly 3 terms and must be written in the form ax squared plus bx plus c. Your answer will be in the form mx plus n, x plus p. To perform a factorization 3, follow the following steps. Ensure that the expression has exactly 3 terms, ax squared plus bx plus c. If one of the letters with power 2 and the other 1 and a number at the end, identify a, b, c, and then you have to multiply the coefficient a to the coefficient c to get ac. Obtain 2 factors of ac that adds to give the value of b. Replace bx with these 2 factors as a coefficient of x. You now have 4 terms. Apply factorization 1 to the first 2 terms and the last 2 terms separately, keeping the sign in the middle. You will now have 2 identical brackets with factors outside. Place the factors outside in brackets, then attach the same brackets. So we're going to demonstrate this using D, 3x squared minus 4x minus 4. So the first step says ensure that the expression has exactly 3 terms, 1, 2, 3. 3x squared, negative 4, and negative 4. With one of the letters with power 2, right, there's the x squared, and the other with power 1, that's the x, and a number at the end, which is negative 4. So therefore, we have to identify what is A, B, and C. Now, when you have an expression like that, it is called a quadratic expression because the maximum power, the maximum exponent there is a square. So that's why it's called quadratic, QUE, quad square. So A now is the coefficient of x squared. So A is 3. A, B, and C are numbers. When you identify A, B, and C, you are going to include the variable x at all. And if there's a negative sign, it belongs to the number on the right. So this is not 4, this is negative 4. So B is equal to negative 4. And C happens to also be equal to negative 4. Then the next step C, to multiply the coefficient A to the coefficient C. Well, not the coefficient, it's supposed to say the constant C, AC. So we're supposed to multiply A times C. So AC is equal to 3 times negative 4. So what do you have for AC? What's your answer for AC?
Negative 2.
Negative 2. Now there comes the tricky part. You say obtain 2 factors of AC that adds to give the value of B. Now there are different ways of doing that. Normally I'll use a set or table setup. I can do the table setup, but there are different ways of doing that. The table setup, let's just go to insert, let's go to a table, and we have different columns. And let's just expand this out. So on one column, we have AC. AC is equal to negative 12. And B now is equal to, well, this must be small b, is equal to negative 4. Is a small letter. Now, as it says, we want 2 factors of AC. A pair of factors. When you multiply, you have to get negative 12. And when you add, you have to get B. Okay. So we must, when we multiply, we must equal to negative 12. But when we add, it must equal, those 2 factors must equal to negative 4. Okay. So normally you start with 1. If you can spot it right away, you start with 1. So because we have negative 12, when we say negative 1, So you can start with negative 1 times 12. Negative 1 times 12. Negative 1 times 12 will give us negative 12. And negative 1 plus 12 will not give us negative 4. Negative 1 plus 12 is not equal to negative 4. So we have to move on. So let's move on to negative 2. Is negative 2 a factor of 12? Yes. So negative 2 times what? That will give us 12. Negative 2 times 6 will give us negative 12. Okay. Now the same negative 2, we have to add it to the same 6 and see if we get negative 4. We are not getting negative 4, we are getting 4. Negative 2 plus 6 is not negative 4. So we have to continue. So let's try negative 3. Can negative 3 go into 12? Yes. Negative 3. Can negative 3 go into negative 12? Yes. Negative 3 times what? That will give us negative 12. Negative 3 times 4 will give us negative 12. Now, will negative 3 add to 4 to give you negative 4? No. So we still have to move on. So let us move on now. Negative 4. Negative 4 times 3 is negative 12. So let us add negative 4 and 3. Will that give us negative 4? No. So we still have to move on. After negative 4 is negative 5. But negative 5 is not a factor of negative 12. After negative 5, you have negative 6. Negative 6, yes. So negative 6 times 2 will give us negative 12. So what if you add negative 6 and 2? Will that equal to negative 4? So yes. So this is our two pairs, negative 6 and 2. Because negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. Sometimes with practice, you will spot it. You'll spot those two pairs, those pairs of factors very quickly. So you don't have to go systematically till you reach it. But if you have not spotted them right away, I would advise you to systematically attempt, it's like trial and error, the factors sequentially of AC. So you must be factors of AC and then apply the addition to see if you get B. And then we have just found out to be negative 6 and 2. So therefore now, it goes on to say that we have to apply factorization 1. No, it says replace Bx with those two factors as coefficients of x, meaning we do not have to write minus 4x anymore. Yes, we continue with 3x squared, and we continue with negative 4. Here they are. We continue with 3x squared, and we continue with negative 4. But we don't write negative 4x. We use those factors. We have to use negative 6x and 2x. It's a plus 2x. So that is what is meant by replacing bx with these two factors as coefficients of x. So negative 6 becomes a coefficient of x and 2 becomes a coefficient of x. So right now we've got 4 terms. You now have 4 terms. And with those 4 terms, it says apply factorization 1 to each pair separately. And we have to keep that sign in the middle. That plus sign that's in the middle, we've got to keep it. So what is basically saying now, we can put an equal sign there, because we can go horizontally just to save space. So the 3x squared, we've got to apply factorization 1 to 3x squared and minus 6. And apply factorization 1 to 2x minus 4 separately. So looking at 3x squared minus 6 separately, between 3 and negative 6, between 3 and 6, ignoring the negative sign temporarily, 3 is the highest common factor. Between x squared and x is the highest common factor. And then we divide 3x into 3x squared, because we are applying factorization 1, which of course we should have mastered by now. 3 to 3 goes 1, so you don't have to write the 1, but 2 minus 1 will give us 1. So we have 3x squared divided by 3x is x, because the 3 cancels out. And negative 6x divided by 3x is 2. We can prove that. So we have 6x divided by 3x, 6 divided by 3 is 2, and the x cancels out. And we keep the plus in the middle. And now we apply, again, factorization 1 to 2x minus 4. Between 2 and 4, the highest common factor is 2. X is not common, so we don't put it as the highest common factor. We don't put it outside the bracket. And now to know what comes inside of the bracket, we've got to divide both 2x and 4 by 2. By a plus 2. So that's a plus 2 right there. So 2x divided by 2 will give us x, because 2 divided by 2 is 1. Negative 4 divided by 2 will give us negative 2. And therefore, this is very important. What's in the bracket must be identical. It says there, you will now have 2 identical brackets with factors outside. So our identical brackets is x minus 2, x minus 2. This must be accomplished. You must have 2 identical brackets. If any one of the terms inside of the bracket differs, then there's a mistake, or probably the quadratic cannot factorize, because it's not all quadratics that can factorize. It's not all quadratics that you will get this being accomplished. That very important step. Not all quadratics that you can accomplish that. Right, so therefore now, having accomplished this, it says, place the factor outside in brackets. So this 3x is supposed to say factors, because it's 2 of them. Place them outside, because sometimes you get 1 as a factor outside. So place them inside brackets and attach the same bracket to it. So your final answer must be like this. Okay, that's what it says from the beginning. Your final answer must be 2 pairs of brackets, mx plus n, open close bracket, x plus 2, open close bracket. It's just like the final answer of difference of 2 squares, because a difference of 2 squares is a special quadratic, as you can see, the x squared. So when you factorize a quadratic, the final answer must be 2 pairs of brackets. So in the first pair, you can put the 3x, there it is, the 3x that's outside there, and the plus 2. And then you attach to it only one of the repeated brackets, which is the x minus 2, and that's your final answer. You don't have to put the factors in brackets first. You can put the x minus 2 first. Okay, so you can just carry down one of the same brackets, and what is outside of the brackets, you put them in a bracket. It's the same because multiplication is commutative. 4 times 5 is the same as 5 times 4. So 3x plus 2 times x minus 2 is the same as x minus 2 times 3x plus 2. And that is the final answer. We have factorized this quadratic. We have rewritten it as a pair of 2 brackets factorized for